We will now have a look to the form component and the various associated components proposed by Tapestry. Tapestry proposes a form component with the possibility of including other components in its body. Using this component will facilitate the creation of an HTML form. Tapestry will automatically convert the data entered by the user to the proper type declared in your Java class. It is also possible to use a validation mechanism in order to check compliance of the data. It is also possible to use a validation mechanism in order to check the data entered by the user. We will use annotation for doing that. And finally, we can implement different methods which will be executed during the form submission. You will be able to associate your fields in your form with your attributes of your Java class, and Tapestry will automatically update these variables. A form emits many events, so we have prepared events for the summation and the rendering of a form. Prepare for submit and prepare for render are used to make a clear difference between form preparation before submission or display of the form. Validate form, a method that contains the system which will validate your form. Success and failure. And finally, submit, the form submission. We will be able to implement these events by annotate our method with the @onEvent annotation. So here is the process of submitting a form. We will first pass through the preparatory phase and validate form, then to the success and failure according to the result of the validate form phase, and we will complete with the submit phase. So do not forget to implement the failure method to avoid undesired operation. To declare a form, you can use either visible or invisible instrumentation. However, we prefer to use the visible one to facilitate the work with the studio. Another tip, we always set the TID parameter because it will often be helpful. It will allow us to include our form in our Java class. We will be able to identify the right method event, and we will be able to include several forms in the same page. We have here an example of using a form with the invisible instrumentation. It is possible to inject this component in the associated Java class with the @component annotation. We have several ways to identify a form. With the TID parameter, this setting will provide a unique reference for each form. If the name and ID HTML attributes are not specified, it will use it to generate them. The TClient_ID parameter is useful for generating the name and the ID HTML attributes. If we do not specify a TID, Tapestry will use the name of the component in order to generate one, and it will automatically add a suffix to make it unique. To declare the action methods, you will still use the @onEvent annotation, specifying the type of action and the component. We have here an example, a method process logging, which will catch the prepare event of the logging form. Tapestry also provides you other useful components. For example, password field and text field, which will be associated to a string type variable. They have some parameters. Value refers to a variable of the class. You have to implement a getter and a setter for this variable. Client ID is the client ID of your component. Label, it is possible to change the label associated to this field through this parameter. And disable, to enable or disable the field. So here an example of the text field component. In the TML, we use the invisible instrumentation with the HTML input tag. It is identified with the TID parameter. Then we map our field to a Java attribute, logging, with the tValue parameter. The checkbox component will be associated with Boolean type attribute, It has exactly the same parameters as the text field, so value, client ID, label, and disabled. The date field component is a simple text field, which Tapestry adds JavaScript calendar. You will have a small icon to the left of the field, with which you will be able to choose a date. This field will, of course, be associated to a date type attribute. With the label, you will be able to generate labels for your various fields. It has just one required parameter, for, which indicates the ID of the associated component. By default, Tapestry will use the name of the attribute to generate the label. For example, for the booking date attribute, the label will be booking date. However, it is also possible to configure them in your properties file by adding an ID label entry with ID, the TID of the component. Now, the component errors, which will be useful for listing the errors in your form. It has no required parameter. However, you can still edit the title block with the banner parameter or its CSS with the class parameter. Example of CSS class that you can use to customize your error component. Finally, the last component, submit, useful for creating a submit button to your form. It has two parameters which are not mandatory, disabled, to enable or disable the button, and label for changing the text label for the button. It is also possible to define an ID label entry in your properties file in order to redefine the label associated to the submit component. This component triggers an event selected. You can catch it in your Java class. Tapestry offers two levels of validation for your form. The first level of validation will be done in JavaScript. To do this, you add either in your TML a tValidate parameter to your fields, or in your Java class, @validate annotation on the attributes associated to the fields. In both cases, they need a list of validators we want to use for this attribute. Tapestry provides some validator required, checks if the value is null or an empty string, max and min check whether a numeric value is between maximum or minimum, max length, min length checks if the string length is shorter or bigger than a specific one, regex checks if the string fits the specified pattern. You can use several validators on the same input. You just have to separate them by a comma. Here is an example of the first level validation. So in our Java class, with the @validate annotation on the attributes or on its setter method. So our password is mandatory and must contain at least 6 characters. Or you can define the validation in your template with the tValidate parameter. You can also declare a part of your validator in the properties file. For example, if your regular expression is too large, it is interesting to export it in order to avoid overloading the template. To do this, simply add an ID validator entry in your file with ID, the TID of the component, and validator, the name of the validator. For example, we have an email field. We declare the value of the regex validator in your properties file by adding the email regex entry. It is also possible to export the error message associated to a validator by adding the ID validator message entry in your properties file. If we take the example of our email, we may add the email regex message entry. Then we have the second level validation, where you will check your data with your database, for example. For that, you will manipulate the validation tracker object in order to record errors. In this example, we have our validate form method, and to record an error, simply use the record error method of your form previously injected. Some other methods you can use: get default tracker to get an instance of the validation tracker, clear error to delete the whole list of errors, and evaluate and get as error to check if the form has or not errors. Finally, you can try submitting a form with a page tester object in your unit test. Just call the submit form method. This method takes two parameters. The first one is an element object that corresponds to your form, and a map corresponding to the data you want in your form before submitting.